Graphing sine and cosine. Before jumping into graphing sinusoids, let's take a look at where these graphs originate from. Sinusoidal waves can be derived by following the trajectory around a circle. Using the graph to the right, let's evaluate sine theta at the following positions. Starting with 0, we draw a line from the origin to 0 on the graph. Think of this line like a very thin triangle, with the vertical side length being equal to 0. In this case, sine theta will be equal to 0. Next, let's evaluate pi over 2. This time our opposite side is equal to our hypotenuse, which gives us a value for sine theta of 1. Repeat these steps for the next two main points on the graph. Notice our last value is negative. This might be a bit surprising, because we can see that our hypotenuse clearly appears to be negative. However, we must remember our hypotenuse is always positive, because a squared plus b squared is equal to c squared. Now that we've derived the main points of a sine wave, let's draw these points on a more traditional graph. Connecting these dots gives us the shape of the sine wave, which we'll be using for the rest of this unit. However, we haven't fully defined the sine wave yet. Let's try some more points beyond what we've tested. As we can see, it seems the sine wave infinitely repeats in either direction. Classifying this repetition is useful, and is called the period. The period is the smallest repeatable chunk or piece of a function. While we're at it, let's also classify another part of the sinusoid. This is the amplitude, which is defined as the distance from the center line to the peak or trough. This value is always positive. The same can be done for cos. Plugging in the same points will give us a graph very similar to sine of x, however it is shifted horizontally by pi over 2 in the negative direction. As we can see, cos of x has the same amplitude and period as sine of x.